Welcome to a lesson with Dr. Powell. Let's take a look at what we had in the last video where we were having a line integral one way and another way, and we ended up getting the same thing. Maybe there was a potential function if we had a complex function f of z is equal to z. Indeed, if this was like a real variable, we could imagine that we just take an antiderivative as follows. Now, this is actually completely accurate. This works in complex numbers too. One reason for that is because we were looking for a ratio of rides to run. It's thought of the same way because we can multiply and add and divide just fine in complex numbers, even though complex numbers themselves are like vectors with two outputs. So, for instance, we just take a regular difference quotient here of this guy right here. And in this difference quotient, it behaves the exact same way as it would computationally in this limit as for a real variable. And so you can expect to get the same thing you would for a real variable, which would end up being z, since that's the derivative of z squared over 2 if it were a real variable. Hence, we can have derivatives just fine in complex numbers and potential functions. So we can get a potential function to move around with line integrals for complex numbers. Thanks for watching.